Hi there, this is Ian McTavish, mentor for Team 4152, and this is part of our training series for the 2024 season. And this is the control system overview that we want all team members to go through. First off, want to give thank you to all of our wonderful sponsors. These were the sponsors for the 2023 season, and then next year we'll be updating this to the 2024 season. So we want to make sure that all team members understand the control system and are able to identify the different parts. There is a little quiz to complete once you have done it. We'll put that in the description. So this is the control system. And basically, if you think of it comparable to the human body, there is a kind of a circulation system, and this provides the power to be able to do things. So that is the kind of the raw electricity. And that is the power that allows a motor to spin or a pneumatic cylinder to move in and out. And though that power is really powerful, so we got to be safety is always our first thing. The other system that we have is kind of like the nervous system. And so this is the system that is sending the signals from our brain and telling things, okay, we want to do this, we want to do that. So this diagram is really useful because it kind of gives you an overview. There's our circuit breaker. So the battery is kind of the key thing. This provides the power for the entire system, and it's connected to a circuit breaker. And that little red button, that is how you power the entire robot off. And there's a little switch when the robot's off. That switch pops out. When you push the switch in, that powers the robot on. So that goes to the power distribution hub, and you can see all these different wires. They're different thicknesses, and those gauges are typically what's used for the different electrical components. So the smaller the number, the thicker the wire actually is. And when you're providing power for things, you're using the thicker wires, and then signals tend to be smaller wires. So we have this power distribution hub. This is where all the fuses go, and connected to that, that's where different motors go, and it is kind of the central hub for power for everything. And then in our nervous system, there's our brain. The radio is used to communicate with the Robo Rio, which is the brain. And this is a Linux computer that basically takes input from different things, whether it's the joystick that we're sending the signal through the Wi-Fi, or different sensors that are built into the robot. And then those signals are what is tells the motors to spin or to stop. And that's the basic overview. We also have pneumatics. We're trying to reduce our use of pneumatics because it just adds a layer of complexity. And the more things you have, the more things that can go wrong. But you've got all of these different components on the robot. Some of them are here just to show you. So for example, Victor SPX, we've used those motor controllers before, but we didn't use them in the 2023 season. So some of these you might not see on our current robot, and it's just to give you an idea of the different things you might see. So we're going to start off with the power and the battery. This is the key thing. This provides all the power for everything here. So we want to very much reduce a lot of risks. A lot of teams have had issues with their battery connections not being secure enough. And what happens if they're loose? Well, you might get an electrical interrupt, which when it's coming from the battery, that interrupts the power on the entire robot. So you want to make sure this is done very, very well. We have wires that connect to these pins, the red and black. And to reduce the strain on them, we never lift the battery from the wires. That's your first quiz question. So pull up the quiz and make sure to enter that. So we always make sure that we carry it properly. You can see this is a lead acid battery. So there's some safety tips with that. And with our safety kit, we have a battery spill kit, and our safety training, we go over how to handle a battery. So when we charge a battery, we have a charger like this, and basically we plug these connectors into the battery, we want to always be careful never to plug them into each other. It's always the battery, and it's always got to be red to red, black to black. When we do the charging, if a battery is fully charged, we'll typically leave it on to continue charging, um, because the longer it's on, the more charge it generates. So we want to make sure that when we're going on the robot, we've got the best charge battery, and that's where the battery beak comes in. We use the battery beak to be able to test the voltage. We can also do that with the multimeter, but this is a handy little small thing that we can just connect and be able to check it out. And then we know that the battery is good. We record that information every single time, and that allows us to keep track of which batteries are good, which are failing faster than others, so that we don't have a battery that's going to be failing on our robot during a competition. So the battery says that it's a 12-volt battery, and what we try to do is we try to make sure that when it goes on the robot, it's actually over 13 volts. If a battery drops down to 10 volts, you might find the robot start to stutter, and basically it just doesn't have enough juice in it. So we want to be careful to not drain a battery too much. And in competition, we always put a fresh battery in. We always double check it and make sure that it's over 13 volts. And that way we should have enough amperage to be able to get through an entire match. And we've had an alliance member once who put a reused battery, and their robot basically died on the field, and thankfully we were able to still win the match. But we want to make sure that everybody's at full capacity. And the circuit breaker, there's a close up. We saw that in the big diagram before, but there's your red breaker button. So that powers everything off. And then this reset switch, if you push it in like it currently is, then the electricity starts flowing. The power distribution hub has all the different slots, and so each of our motors gets plugged into one of these slots. There are 20 slots, and we can put in different breakers from 40 amps to 20 amps. And there is documentation. So it's really important as we're using things, always take the time to read the documentation and find out, what are the tips and tricks and safety features. So take the time to read that. We also have some older PDPs that we use on some of our off-season robots, and that's over the years you'll see we've got different electronics from previous years and things. So some of them are old enough that we're never going to put them on a competition robot, but for an off-season robot, it's a great way to learn. And this is an example of the breaker. And so with the breaker, in the rules, it's very strict about certain things. So if you have a motor, it needs to have a 40 amp breaker. If you have something that's smaller, you want to make sure it's got the appropriate breaker so it cuts out at the appropriate time. And this is a big thing, is making sure that the breaker is fully seated, and that we only have breakers for the items that are plugged into there. The other thing is that we can actually in code have the motor stop at a lower amperage. So we often do that to make sure that we're not in a situation where something's going to get burned out. We also have a mini power module. We've used this. We include a lot of other electronics. If we have 3 to 4 cameras on a robot, then they don't take as much amperage. So we'll use a mini power module to power them. And this is actually connected to the main power distribution hub, but allows us to have more slots for small things that don't draw much current. Now with the brains. So this is the Robo Rio, and it is a full computer. We have different Robo Rios. There's version 1 and version 2. The way you can tell them apart, version 2 has an SD card slot, and we have a little thing that we mount on our Robo Rio to ensure that the SD card can't pop out, because that actually happened in a match. So we need to make sure that that's always secure. And This robot basically, or the Robo Rio, allows us to control it. You have different connections here. I'm going to quickly go over them. So the Ethernet connection on the robot plugs into the Wi-Fi router. You can also plug your laptop directly into it. There's USB connections. There's your main voltage, so that's what's powering the Robo Rio. Then your CAN bus wire, so that is what we use to control a lot of our motors, and that is a key source of potential issues. So it's making sure it's done. We try not to use the I2C because there's a glitch with that. And we have different connections, so digital inputs and outputs. We have for relays and analog and PWMs, but most of our things are connected through the CAN bus system, and we rarely use some of these other connections. And then there's the radio signal light as well. With the radio power module, this device allows us to power the radio, and so we like using that. The problem with the Wi-Fi radio is that it's got a little barrel jack, and a barrel jack can easily fall out. So having a powered Ethernet where it's got a tab is a great way to do it. We're looking forward to 2025. They're going to be introducing a new radio. And there's the radio right there. So the biggest thing with the radio is that when we go to competition, you need to have it configured. And so when we come back from competition, we need to immediately reconfigure it so that otherwise we can't drive the robot around. And you'll see there's status lights. We've got steps on how to configure the Wi-Fi radio. It's really important to follow those steps, because if you don't, there's lots of ways that it can go wrong, and it can be really frustrating. So it's a matter of following our procedures. The CAN bus wire, so you'll see yellow and green. We may switch to white and black for this, simply because we have an inexpensive way to acquire white and black wire that's the right gauge. So with the CAN bus, basically it's 22 AWG, and you'll notice that they are actually twisted around each other. So this helps reduce some of the signal noise that can go through. And with this kind of wire, this is really important communication. So we want to be really particular about how they're connected, so that everything, how long they are, and we want to make sure to keep them away from magnetic fields such as motors. So really important how these are wired. This is one of our more common motors on our robot. So the Neo motor is a very powerful motor. It's got a good speed, so it's really useful for a lot of situations. It needs to be run with the SparkMax motor controller, and there's basically a red, white, and black wire that goes to the Neo. This is a brushless motor, so you have the 3 wires to control the phases of the motor, and you also have a little port here, and there's a little cable that comes out that's got to be plugged in for this to work, and that provides the information to the sensor and everything. And we use CAN bus for this because then we can get different values. So it has a built-in encoder. We can find out what the speed is. We can determine the amperage, so that can help us determine if it's stalling, and really useful. We've got a variety of sensors. The Limelight camera is a huge sensor for us. We have some other cameras as well, but basically we're able to use this in a variety of ways. One way is with the April tags that are on the field. This can identify them, and then we can use that information to determine where the robot is in physical space. So that is crucial for a lot of our autonomous routines and for our artificial intelligence assisted driving. So that's a brief overview of some of the key components, so everybody makes sure that they understand it. Thank you very much for your time.